Alright guys, lesson 5-3 is called slope-intercept form, and this chapter is really important, so make sure you copy down all of the formulas and the vocabulary and stuff. So the objectives here would be to write linear equations in slope-intercept form and then be able to graph linear equations in slope-intercept form. Okay, so this getting ready box, I think this is a really good example. So it says, bamboo can grow very quickly. The graph models the growth of a bamboo plant. Find the point where the line crosses the vertical axis. So vertical is up and down. So that point would be right here. Let me make it pink. It looks like it's about at a height of 20. What does this point tell you about the bamboo plant? Well, if you look at the two variables here, we have height, which is the vertical axis, and then time in days, which is on the x-axis. So when the time equals 0, so our very first value here, this ordered pair would be 0, 20. So after 0 days, the height of the plant was 20. So what that is telling you is that the bamboo plant started out at 20 feet. Okay, so it starts at 20 feet. Okay, then it says find the slope of the line. So if we were to find the slope of this, we would do rise over run. Now you have to be careful. You have to look at your scale. So if we make this bigger, it looks like if you go up one block, now it looks like every block is 10. So it looks like we went up 10, rise 10, and then run 10. So 10 over 10 equals 1. So what that 1 represents is that it's going up 1 foot per, and then the x-axis would be days. So 1 foot per day. So it's starting at 20 feet, and then it's going up 1 foot per day. So this is an example of slope-intercept form. The equation for this would be you take the slope, which would be 1 foot. So our equation is going to be y equals 1x plus your y-intercept, which would be 20. So as we start to do these more, you want to recognize, it's really easy when you just have a graph to pick out the slope and the y-intercept, but we want to start putting meaning to them. So the y-intercept is where the situation actually begins, and then the slope is actually just your rate of change. Okay, so this is the important vocabulary here. We have a linear equation. So we've had equations like this before, like x plus 3 equals 5. That's not a linear equation. That's just an equation in one variable. So a linear equation models a linear function. So you have to have x and y. You have to have an input and an output for it to be a function. So that's why that's not linear. And variables cannot be raised to any power other than 1. So something like this, 3x plus 5. That's a linear equation. But something like this, y equals 3x squared plus 5, that's not linear because you're raising the variable to the second power. And anything that's like x cubed, anytime the variable is raised to an exponent, it would be non-linear. Okay, then solutions to this up here, x plus 3 equals 5. Well, you would just solve it. You would subtract 3 from both sides and you get x equals 2. 2 would be solution. But the solution to something like this, 3x plus 5, you're actually going to graph this line, and any point that falls on that line is a solution to the equation. So there's infinite solutions to linear equations because the lines extend forever in both directions. Now this is the important part, slope-intercept form. So the formula that you have to memorize is y equals mx plus b. Now the x and the y, those just make up an ordered pair because we're going to graph this and it's going to get graphed on an x-axis and a y-axis. So you have all these points, you have all these ordered pairs. Well, those have values. Those are going to have an x value and a y value. So that's what the x and y are. That's what the x and y are. And that's going to be in every equation we do in this whole chapter. You're always going to have an x and a y. But the important part, m represents the slope and b is the y-intercept. An intercept just means to cross. So the y-intercept is the point where the graph crosses the y-axis. So in this graph I have right here in pink, That would be the y-intercept. And there's two ways to find slope. Slope could be rise over run, and that's how you're going to find it if you have a graph, or you could use y2 minus y1 over x2 minus x1. Okay, so problem 1 is identifying slope and y-intercept when you have an equation. So the first equation we have is y equals 5x minus 2. So the slope of this equation, if our formula is y equals mx plus b, the number that comes in front of x would be the slope. So in this first one, the slope is 5. And then the number that comes at the end, or that's not right next multiplied by the x, would be the y-intercept. So the b, which is the y-intercept, is negative 2. And the ordered pair for that would be 0, negative 2. So you can write it either way. Alright, and the second one here, our slope, because we have negative 3x, the slope is going to be negative 3, and the y-intercept is going to be 10. And so the ordered pair would be 0, 10. Because y-intercepts, they all cross the y-axis, and any point that crosses this y-axis is always going to be like 0, 1, 0, 4, 0, 7. So they always have the form 0, number. Okay, problem 2 is writing an equation in slope-intercept form when they give you the information. So anytime I see what is an equation of a line with a slope of negative 4 over 5 and a y-intercept of 7, we're going to learn different formulas. So eventually they'll have to be more specific, but they'll say write it in slope-intercept form. So I always write down y equals mx plus b, so I know what the form is actually supposed to look like. So this one, if the slope is negative 4 over 5, that's going to go in for m. So I'm going to have negative 4 over 5. So you always have y equals, and you always have this x. So I have negative 4 over 5 in for the slope, and then the y-intercept is 7, so I just write plus 7. And then the second one, what is an equation of a line with a slope of 3 over 2 and a y-intercept of negative 1? Here's my formula, y equals mx plus b. So I'm going to now have y equals, the slope is 3 over 2, so I'm going to put that in, x, and then the y-intercept is negative 1. So instead of writing plus and negative 1, I'm just going to write minus 1, and then that'll represent the y-intercept was negative 1. Okay, writing an equation from a graph. So I'm going to kind of just zoom in on this graph, and we're going to write the equation and then look at the multiple choice. So if your formula is y equals mx plus b, you need to find the slope, and you need to find the y-intercept. Well, the y-intercept is really obvious from a graph. It's just where the line crosses the y-axis. So it crosses right here at negative 2. So I know my b, or my y-intercept, is going to be negative 2. Then you have to calculate your slope. So anytime you have a graph, use rise over run, but make sure you look at what each block represents. You look at the units, but it looks like here each block represents 1. So I'm going to rise 2, and I'm going to run 1. So my slope, rise over run, is 2 over 1, which is just 2. So if I put that in where my slope goes, I have y equals 2x minus 2. And this was a multiple choice one. So which one is 2x minus 2? That was D. Okay. Alright, now this is where it gets a little bit tougher. Writing an equation from 2 points. So if you have to write an equation in slope-intercept form, that's y equals mx plus b. Now, if they give you an ordered pair that's a y-intercept, say for example they gave us, instead of 2, 1, they gave us 0, 5. Well, we know 0, 5 is the y-intercept, so we would just put a plus 5 at the end. But because they didn't give us the y-intercept in either ordered pair, first thing we got to do is find the slope. So to find the slope from 2 ordered pairs, we do y2 minus y1 over x2 minus x1. So y2, let's see, if I write the ordered pairs side by side, because sometimes that helps, 5, negative 8. Okay, so y2 is negative 8 minus 1, and then we have on the bottom, we have 5 minus 2. So let's see, we have negative 8 minus 1 would be negative 9 over 3, which is equal to negative 3. So that's our slope. So this is what we have so far. Y equals negative 3x plus b, because we don't know our y-intercept. So if we're going to solve for b, we have to leave that as it is, and you're going to pick either ordered pair you want. Now, if I'm going to pick this one because it doesn't have any negatives in it. Now, in this ordered pair, 2 is your x value and 1 is your y value, because that's how all ordered pairs go. So I'm going to substitute those two numbers in to this equation that I have so far. So my y value is 1, so I'm going to put a 1 there, and then I have negative 3 times x, but my x value is 2. So I'm going to insert 2, and then I still have plus b. Then if I solve this equation for b, that'll tell me what my y-intercept is. So I have 1 equals negative 3 times 2 is negative 6 plus b. And then this is just a one-step equation. I just have to add 6 to both sides, and I get 7 equals b. So I know my b, I know my m, I can write my equation. It's y equals negative 3x plus 7. Okay, this is probably the toughest part of this whole chapter, because there's a lot of steps right there. So let's do another one like that. Okay, write an equation in slope-intercept form. So y equals mx plus b that passes through these 2 points. So here's our 2 points, 3, negative 2, and 1, negative 3. So we need to find the slope. Because neither of those ordered pairs are the y-intercept, the only thing we can do right now is find the slope. So y2 minus y1 over x2 minus x1 is going to be negative 3 minus negative 2 over 1 minus 3. So let's see, subtracting a negative changes to plus. So negative 3 plus 2 is negative 1 over 1 minus 3 is negative 2, and negative 1 over negative 2 is 1/2. Okay, so now that's my m. So I have m equals 1/2. So I'm going to write my equation. So far, I have y equals 1/2 x plus b. And I'm going to pick either ordered pair. So since they both have negatives, it doesn't really matter. I'll just pick this one right here. And I'm going to put my x value in for x and my y value in for y. So my y value is negative 2 equals 1/2 times my x value, which is 3, plus b. Okay, so that equals that's negative 2. 1/2 times 3 is just 3 over 2 plus b. Okay, and 3 over 2, I guess we could write as 1.5. So I have negative 2 equals 1.5 plus b. Then to solve this equation for b, I'm just going to subtract 1.5 from both sides. And negative 2 minus 1.5 is negative 3.5 equals b. So then my equation is y equals 1/2 x minus 3.5. Now, usually if you have one of your values as a fraction and the other as a decimal, you should have a little consistency. So it's probably best to either write it as y equals 0.5x minus 3.5, or write them both as fractions. Y equals 1/2 x minus 3.5 is 7 over 2. Just so you don't have one that's a fraction and one that's a decimal. It really doesn't matter, but it just makes it look better if you keep them both the same. Okay, and the last part here is graphing a linear equation. So here's our formula, y equals mx plus b. And I don't know if this is technical terms, but an easy way to remember what m is, m means move. That's how you're going to move up, down, over on the graph. And b means begin. So that's where you're always going to start. So what is the graph of y equals 2x minus 1? Now when you guys graph these, I'll give you nice grids, but I just drew this on there so I could show you. So you're going to begin at your y-intercept, which is negative 1. So this right here is the origin. So we're going to come down 1 on the y-axis. You always got to start at the y-axis. We're going to begin at negative 1. Then we're going to move based on what the slope is. Now, if the slope is 2, we need to have a fraction because we need to have rise over run. So we're going to make that 2 over 1 because any whole number you can just put over 1. So you're going to go up 2 blocks over 1. Put a dot there. Up 2 blocks over 1. Put a dot there. You really only need 2 dots, but usually if you have 3, it just helps you make a straighter line. And then I'll give you rulers, and then you just connect the lines all the way through. Like, one thing some people do is they usually just go from dot to dot, but it actually goes all the way through with arrows on both ends because it goes in both directions forever. So now every one of these points that fall on this line is a solution to this equation. Okay, and one more of those. So what's the graph of negative 3x plus 4? So we're going to begin at the y-intercept, which is 4. So up here at positive 4, 1, 2, 3, 4. Right here is positive 4. Now our slope is negative 3. So we got to make that a fraction, make it negative 3 over 1. Now because it's negative, we're going to come down 3 blocks. 1, 2, 3. And you always run from left to right. So a lot of people think you come down 3 blocks and then go over this way. But you don't want to go over that way because it's a negative slope. So if I connect these, that looks like a positive slope, but you can just by looking at the graph, but the number's negative. So if I get rid of that, alright, I can't get rid of that, I guess, so I'm just going to erase it. We don't want to go this way. We want to start at the 4, come down 3 blocks, and then you always want to run from left to right. That's the same whether it's positive or negative. And then come down 3 blocks again, come over 1, and then I missed my points. But you connect your 3 points with a line, and then any point on that graph, any point on that line would be a solution to the equation. Okay, so try the lesson check on page 311. There's 6 problems there, and then we'll go over them tomorrow.